So this is chapter 4, My Open Math, number 21. And somebody asked for some help. I recommend that you watch the video that James Susser did about using a table to do this. I honestly like that better than using the tree diagram, but I thought just because somebody asked for some help with it, I figured I'd do this instead of the table method. It's because they are saying make a tree diagram. So a certain virus infects 1 in every 300 people. So 1 out of 300 is the probability that a random person has a virus, and if I subtract 1 from 300, I get 299 out of 300 people are negative. They don't have the virus. And then it says 85% of the time that a test will, if somebody actually has a virus, it'll catch that they have the virus 85% of the time. And if I find the complement of that event, subtract from 100, that 0.15 is the probability that somebody has the virus, but the test misses it. Then they go on to say in the problem that 8% of the time, if a person will test positive if they aren't actually infected, so it's a false positive. So here's the they don't have the virus branch. 8% of the time they'll get a positive test result, and 92% of the time they will not. So I subtracted that from 1. And we have to find, okay, so now we're going to test what's the probability that the test will be accurate. It actually, somebody will actually have the virus and test positive, given that they were tested positive. So I went back to page 145 in the textbook and found this problem, these two problems. Well, let's see, I can show you. These are the two problems. I guess it's 146. These are not independent events. For one thing, the probability of being infected is not the same as a probability of testing positive. So we know they're not independent. They're dependent. So we're going to use this formula. And this looks pretty complicated. What I tried to do is write it out in words for you. Maybe that'll help make it a little easier. So we're trying to, putting the words of this problem into this formula, I said the probability of testing positive and being infected is this part, equals the probability of testing positive times the probability of being infected, given that they tested positive. And this is what we're looking for, right? So the algebra part of it, if I can find this number and I can find this number, all I have to do is divide this by that. Okay, so how do we find, now the trick is, how do we find these numbers? So as I pointed out in my tree diagram earlier, I just set up the branches with the different probabilities. And to get these ending numbers, all I did was multiply. I went 1 divided by 300 times 0.85. That represents the probability. Now, because I'm multiplying, this is an and probability. This is the probability of somebody being infected and testing positive. This is the probability of somebody being infected and testing negative. Remember, it's an and probability. We multiply the probabilities. This number is the probability of somebody not being infected and testing positive. And lastly, this is the probability of somebody not being infected and testing negative. So the test was accurate here. So what we've got to do is find so the probability of somebody testing positive and being infected is this number right there, right? Testing positive and being infected. We need to find the probability of somebody testing positive. It isn't just the 0.85 or the 85%. So what I did is the probability that somebody's testing positive is represented here, because this is the positive test result and this is the positive test result. So I needed to add those two numbers there, and that's where I came up with that. So this number, here, let me grab it. Let's see. So this number divided by this number, that's the probability of testing positive. Then multiply that by 100, and then make sure you give enough decimal places, is that answer. Now, to answer question number B, letter B, it's a very similar kind of thing. The probability that somebody tested negative and not being infected is that number right there. They were not infected and they didn't test positive. That was the test was right. It called it right. Is that number? So that's that part. Now we got to worry about the probability of somebody testing negative. Well, we've got these people here. This probability here represents, yeah, they were infected, but the test missed it. So that's testing negative. This is testing negative. We have to find the sum of those two numbers. That's what goes here. So, and this number is the probability of testing negative and not being infected. So let me grab that. That's the numerator. And we're going to divide by the probability that somebody tested negative. And let me be official and put a division line between that. And multiply that answer times 100. And it's pretty darn close to 100%. Okay, so that's how you do this kind of problem using a tree diagram. Take a look at his Dr. Seuss or James Seuss's program video with the tables. I honestly think it's better than this, but maybe this will help you too. Different ways to learn.